Hi, I'm Randall Carr, and I'm the CEO of Bechtel Construction.
Hello, my name is Matthew Rowan, and I am the Chief Financial Officer.
Okay. Hi, my name is Thomas Gibbs, and I'm the Sustainable Development Manager here at Bechtel.
Hello, this is Wei Xiaowu, the President of Bechtel's Oil, Gas and Chemical Business.
Hello, my name is Wen. I'm the President of Nuclear Security and Environmental Business.
Hi, I'm Kiefer Bennett, President of the Infrastructure Division at Bechtel.
Hi, I'm Ryan Merkel, President of the Mining and Metals Division here at Bechtel.
Hello, this is Matt Brannick from Team Bechtel representing the Madison, Wisconsin office.
Hi, I'm Sabrina Taylor, the Human Resources Director at Bechtel.
Hi, I'm Joseph Spadoro. I'm the Manager of Engineering and Construction here at Bechtel.
This video is made for the term project of CEE 420 construction productivity from Team Bechtel. We observe a size from the video. This video is uploaded to the YouTube on May 16, 2011, and it shows the brick laying process for 6 minutes. From the video, we can see that it is a sunny and clear day, and the temperature is moderate by judging the clothes of the workers. Let's see the executed summary of our project first. Basically, we are improving the productivity of laying down paving bricks, and we observe the placement of solid bricks through the Tiger Stone machine to form a zero-graded brick roll. And there are 5 crew members, 1 bricklayer, and 1 bricklaying machine on the side. And we are going to use the crew balance chart, process chart, and flow diagram to analyze the existing and proposed plans.
Hello, this is Matt Brannick, and I'll be talking about the area of study. Basically, we saw that there are 5 workers in the video. 1 worker was cutting bricks, basically along the edges. There are 3 workers arranging bricks into the Tiger Stone paving machine, and 1 worker was simply just operating a small loader, basically transporting the bricks from storage to the Tiger machine. Then there are basically 2 pieces of equipment in the video. As you saw, there was a Tiger Stone machine that ran off electricity. It helped them place the brick and increase their productivity, and definitely made it easier for the bricklayers to put down the bricks without having to bend over, get it on their knees, and all that tough work. The other machine was the front end loader, which was designed to just transport the bricks from the storage area to the Tiger Stone machine. And finally, the hardest, most labor intense portion is the guy who was falling behind with the cutter. He had to fill in the edges, and he was down on his hands and knees, had padding on his knees, and was required to use the most amount of skill in putting down and filling in the areas that were missed.
Next, we're going to talk about methods of study. 3 methods are used in the analysis: crew balance chart, process chart, and flow diagram. Crew balance chart illustrates sequential activities carried out by the crew with respect to time. It shows the activity time of all workers and equipment in one cyclic task in vertical bars. Crew balance chart allows the project manager to review performance and possibly optimize execution to operate at maximum productivity levels. The next slide shows an example for the crew balance chart. The process chart is a graphical presentation of all operations, inspections, delays, and storage occurring during a process or procedure. Process chart has 3 main tabs. Man tab records what the worker does. Material tab records what happens to material. Equipment tab records how the equipment is used. Flow diagram is a graphical means of presenting, describing, or analyzing a process and movement of material or man. Flow diagram shows the relative position of the machine, fixture, and make the path followed by man and material.
We will now discuss the existing operation and the problems that go with it. As you can see, there are 5 workers performing this activity. There is a skid steer operator, a stone cutter, 2 bricklayers, and a Tiger Stone machine operator. Overall, the productivity of this activity goes up when using the Tiger Stone machine compared to laying the bricks by hand. However, the stone cutter is the reason that productivity is not at its highest potential. The stone cutter can only cut and place 7 bricks per cycle on average, while the Tiger Stone machine creates 12 areas that needs bricks to be manually cut. This is a huge problem that drops the productivity of this operation. Another problem is that the skid steer cannot evenly drop bricks throughout the whole machine, which causes workers to stand really close to each other to grab bricks. This unnecessary problem causes congestion on the machine and slows productivity. The process chart and flow diagram shown are used to visualize the activity.
When deciding which plan to implement, we used cost analysis to determine which plan would be most cost effective for improving the given activity. Using RS means data, we estimated the direct cost of each activity, including labor, material, and equipment costs. We summarized each of these costs in tables shown. By using the daily output, base wage values, worker compensation, average overhead, and crew composition, we were able to determine the labor costs. We also included a city index, assuming that the activity would take place in Champaign, Illinois. Some other assumptions that we included in this cost analysis are as follows. We assumed that the Tiger Stone bricklayer can lay a maximum of 3,229 square feet per day. This is directly from the website, which shows the Tiger Stone bricklayer. All labor unit costs and factors were obtained from RS Means 2016. The skid steer loader is assumed to be a 78 horsepower diesel type machine. The operation and ownership cost of the Tiger Stone bricklayer was assumed to be about $25 per hour. The material cost of the bricks were assumed to be $3.96 per square foot. When we analyzed the implementation plan of using pre-cut bricks, we assumed that there would be a 5% increase to material costs if we requested this from the manufacturer. While not all the improvements had a significant change in the unit cost per square foot of work done, they did in effect shuffle the costs from different categories, which can have benefits in and of itself.
After observing the video of our construction activity and identifying some of the issues with the process, we began to come up with a few solutions to remedy these issues. As mentioned before in the existing operations and problems section, one of the issues we observed was that the stone cutter was struggling to keep pace with the machine. As a result, our first proposed improvement is to add an additional stone cutter to the crew. In order to complete the pattern, each triangular area needs 3 bricks cut and placed on each side. Each cycle needs 6 bricks on each side of the pathway. That's a total of 12 bricks that need to be cut and placed per cycle. However, we observed in the video that a single stone cutter can cut and place 7 bricks per cycle. This is 5 bricks below the pace needed to keep up with the Tiger Stone. The addition of the second stone cutter brings the productivity of cutting and placing bricks more into accordance with that of the Tiger Stone. Additionally, in the event the stone cutters catch up and are waiting on the Tiger Stone, the extra stone cutter can join the bricklayers on the Tiger Stone in helping to arrange the bricks. Adding this extra stone cutter will increase the productivity of the crew, allowing each stone cutter to remain on one side of the roadway. This reduces the time the original stone cutter may have spent walking from one side of the pathway to the other. Additionally, this also increases the safety of the operation, with there being no need for the stone cutters to walk back and forth across the pathway and into the loader's path.
Improvement number 2 details the addition of a stone cutter to the crew. This would be the second stone cutter in the crew. This addition would increase the productivity of the operation. Both stone cutters start off by gathering loose brick from the previous cycle, decreasing the amount of dropped bricks abandoned per cycle. 2 stone cutters would be strategically placed on each side of the Tiger Stone paving machine. In the original setup with 1 stone cutter, it was noticeable that their productivity was lagging behind the pace of the Tiger Stone machine. Adding a second stone cutter would assist in closing the productivity gap between cutting and placing brick and the machine churning out finished road.
Proposed improvement plan number 3. We added a flatbed truck instead of the skid loader. The bricks will be neatly sorted on an operated flatbed truck that will follow the Tiger bricklaying machine at a level height for the 3 brick layers to pick up and to place into the Tiger machine when needed. The flatbed truck would then push the brick piles horizontally towards the brick layers so they do not need to move from their stationary positions. The purpose of this is we have less cost when compared to the skid loader, no potential safety risk for the stone cutter, no brick droppage causing bricks to break into pieces, and an overall lower material cost. The crew balance chart shows the following, with the replacement of the skid loader and the skid loader operator. The flatbed truck will be supplying the bricks to the 3 brick layers at a constant rate through the 2-minute cycle. The flatbed truck operator will move the truck forward at each point the Tiger laying machine operates. A stone cutter will be needed for the cut and brick placement for the side pieces of the road. The stone cutter will not be performing the task of gathering the stone from the previous cycle because with the flatbed truck there will be no droppage of bricks. The summary cost of adding a flatbed truck and removing the skid loader is shown on the chart below. We have 2 pieces of equipment. Number 1 is a flatbed truck and number 2 is a Tiger stone bricklaying machine. We use the RS Main resource to find the hourly operation cost, rent per day, equipment cost per day, city index, equipment cost per hour for the flatbed truck. We had to Google for equipment costs for the Tiger bricklaying machine because the RS Means did not have it listed. With all these calculations, we calculated the total hourly cost to be $124.37 and the unit cost per square foot to be 32 cents. Our summary cost analysis and unit cost consists of material, labor, and equipment costs. Each cost is calculated by square foot. By adding up all of our unit costs, we came up with a total of $5.12 per square foot.
The implementation of Improvement 2 ordering pre-cut bricks will maximize efficiency while decreasing cost. Prefabrication in off-site facilities is a technique increasing in popularity as they have known benefits including decreasing overall project costs, decreasing schedule times, improving overall construction quality, and allowing for more efficient use of both materials and labor. Shop cut bricks will allow for precise cutting, will create elements that are easier to install, and will remove external elements hindering operations. Additionally, for our cycle, prefab will allow for removal of a worker.
To conclude, after analyzing the existing operation thoroughly through crew balance charts, process charts, flow diagrams, and cost analysis, we found that the existing operation was not as efficient as it could be, and therefore came up with various improvement strategies. One of the main problems with the existing operation was the slow pace of the stone cutter, who was struggling to keep up with the pace of the Tiger bricklaying machine. To solve this issue, our second improvement plan details the utilization of pre-cut bricks, eliminating the need for this stone cutter and thus reducing crew size and labor cost. This strategy also improves efficiency by decreasing the cycle time as well as improving safety, and is therefore why we chose this improvement plan over the others. Of course, with any operation, there are drawbacks, which in this case would be the increase in initial cost due to prefabrication of pre-cut bricks, as well as the need to separate the central bricks and edge bricks when laying. However, overall, the advantages far outweigh the disadvantages in this implementation plan, and therefore is the reason it was pushed forward.